Okie dokie. In this problem, they say, according to someone's law, the resistance to flow in a blood vessel R is directly proportional to the length L of the vessel and inversely proportional to the fourth power of the radius R of the vessel. And then they give us a bunch of information, and the goal is to eventually find capital R. So let's talk a little bit about directly and inversely proportional. So if they ever tell us that y is directly proportional to x, what that means is we can write the equation relating x and y in this manner. Y is equal to k times x, where k is just some constant. So to be directly proportional, let me reword that. When y is directly proportional to x, y is equal to k times x. Now, inversely proportional, if y is inversely proportional to x, that means that y is equal to k divided by x. So the big idea is whenever it's directly proportional, you will see the other variable, what I will say, in the numerator. The variable will be in the numerator if it's directly proportional. The variable will be in the denominator when it's inversely proportional. All right, let's get started. So they say R, capital R, is directly proportional to L. So that means R can be written as K, the constant, times L. But R is also inversely proportional to the fourth power of the radius R. So inversely means whatever variable they're talking about or whatever term they're talking about will be in the denominator. And so they have the fourth power of R, which means R to the fourth. So we're combining the two things they tell us to make one equation for capital R. Okay, so we have R is directly proportional to L, that's why L is in the numerator, and inversely proportional to the fourth power of R, that's why R to the fourth is in the denominator. So then they give us R equals 163, L is equal to 14, and radius is equal to 5. So starting with that information, we are going to solve for the one unknown. So let's plug in what we know. We know that capital R is 163.2. We don't know K. And we know L is 14. And we know R is 0.5. So we're going to plug in 0.5 for little r here for the radius. And naturally, what this will allow us to do is solve for k, since k is the only unknown in this equation, okay? So we can do this a number of ways. If you want, let's go ahead and calculate, I guess, just whatever 14 divided by 0.5 to the fourth is. So what we can do is kind of separate this k from this stuff here, right? And let's just open up Desmos, whatever calculator you prefer, really, but I will use Desmos. And what I'm going to do is just calculate the value that's multiplied by this k here. So 14 divided by 0.5 to the fourth power. Nicely, that is 224. That's pretty good. Okay, so we just have k times 224 is equal to 163.2. So now to get k by itself, we divide by 224. So let's do that in Desmos. 163.2 divided by 224, and we get an ugly k value of 0.72857. All right, not the nicest, but let's use what we have here. So let me rearrange a couple things here. Give me just a moment, and let's talk about our next step. So we have our k value. Now they say, what is capital R when the radius is 0.7, but the length is unchanged? So we're calculating capital R. We are plugging in everything we know now. We know that k is 0.72857. Also, we are re-plugging things into this. We're kind of restarting, if that makes sense. So this is our k. Our L is unchanged, meaning it's still 14. And R is now 0.7. And make sure to raise R to the fourth. So now we can plug all of this into the calculator to calculate what capital R is. Let's break out Desmos again. So we're calculating this straight up. And let's go ahead and plug this in. 0.72857 times 14, and we'll just divide that by 0.7 to the fourth. Don't worry about all of that not being over that value. This is still equivalent, so hopefully, if we've done that right, we've gotten 42.48. Let's see how we did. 42.5 is an option, and that matches what we have. So I think that's pretty solid. All right, hope that made sense. Take a good look there. Let's do one more example. Why not? Let's break out the little pinky purple color there. Let's do this a little bit faster. What do they tell us? They say R is directly proportional to L and inversely proportional. Oh, this is like the same problem. Do they switch it up at all? I think I actually have one more here. Are these all the same? Dang, that's no fun. All right, in that case, I'm sorry. I'm just going to do one more of these. I had two more, but if they're all the same, then there's really no point. So R is directly proportional to L. So we have K times L. And I might just go ahead and keep it kind of separate like this. And then inversely proportional to the fourth power of R. So inversely proportional to R to the fourth. So it's going to be the same exact setup as the last one. Now, just different values, right? So 142.6, 12, and 0.5 for R, L, and little r, respectively. So 142.6 equals K, which we do not know, times 12 over 0.5 to the fourth. So we're going to start by calculating 12 over 0.5 to the fourth. Just kind of change this here to a 12. There we go. 12 over 0.5 to the fourth is 192. So we really have K times 192. And then we solve for K by dividing by 192. So 142.6 divided by 192, I believe. Yep. So we get about 0.7427. K is equal to 0.7427. And now we use that, and we sort of restart this equation, right? So we restart plugging in values. Let's use green now. We'll use capital R. I'm assuming, yeah, all these are asking, yeah, they're all asking for capital R. So the whole process is the same process every time. I don't know if I just got lucky getting the same exact setup every time. I don't know if that's supposed to happen, but anyway, so we're plugging things in. We have L is unchanged, and then the radius changes from 0.5 to 0.7. So now we're just dividing by 0.7 to the fourth. Okay, not too crazy. Let's open up Desmos. We got 0.7427 times 12. Divided by 0.7 to the fourth, and we get about 37.12, 37.12 as our capital R, and that is equal to, or that is, equivalent to option B there. Hope that makes sense. Same process for each of these, and it would be the same process for this one if you want to go ahead and try this one out and give it a shot on your own. I'm going to reveal the answer in 3, 2, 1. The answer is option D if you want to give that a practice run. But yeah, I'm not going to work that out. It's the same exact process as these two. I hope this helps. If you have any questions, you let me know. All right.